Welcome friends in lecture 5, lesson 8, motion. Now in this particular lecture we are going to learn with the important part of this lesson, that is equation of motions by graphical method. There are three equations of motion, that is V, first equation as V is equals to U plus AT, second equation is equals S is equals to UT plus half AT square, and the third equation is 2as is equals to v square minus u square. In all these three, v is the final velocity, u is the initial velocity, s is displacement, t is time, and a is acceleration. Now the first relation that we are going to start with for the graphical method is velocity time relation. Now in velocity time relation we can take an example like car is moving with an initial velocity of v and reaches to the final velocity. So according to that we have drawn a graph. The final velocity is v on the y axis and initial velocity is u, right, and starting point for the time is 0. So at time t is equals to 0 the initial velocity was u, right, and after a certain point of time you can see a line is traveling in a straight line. So u is the time at t is equals to 0 and final velocity when it reaches, that is v, the time is at t, okay, small t. So here as we have drawn the graph, we need to find out quantities as v, a, u and t. So here just for the understanding, OA, as you are seeing on the graph, OA is an initial velocity, that is u, and OE on the same axis you are seeing O to E, that is v. So you can say in the straight line also like DC, so OA is equals to DC is equals to u, and OE and BC both are v. In the same way OC is equals to T from 0 to T, that is T minus 0, it will be T only. In the same way AD is also T because it is having the same section from on the x axis, so that also will be T. So here taking some mathematical values BD, suppose if on the y axis on the other side if you want to take BD is a section of 2. Now directly we don't have BD, so what we are going to do, that is BC minus DC, BC minus DC or CD, so that will be equals to V minus U, that is going to be BD as in length. What is acceleration here is how we count acceleration. Acceleration is nothing but change in velocity with respect to time. We have done in the previous lecture of acceleration. So A acceleration is equals to BD. Now you see that acceleration velocity time graph last time we have done. On the graph if it is a uniform velocity, it's an acceleration, the straight line is an acceleration. So with a mathematical slope, that will be BD upon AD. So what will be acceleration, will be BD upon AD, that will be equals to BD upon time, BD upon time t. Now since AD is equals to t, so you can say that A is equals to BD by t. So AT, BD will be equals to A into t. So here we get a second equation, that BD is equals to acceleration into time. Keeping equation 1, taking equation 1 and taking equation 2, if we merge both the equations, we will get V minus U is equals to AT. V minus U is equals to AT, or acceleration is equals to V minus U by T, or you can write down that V is equals to U plus AT. V is equals to U plus AT. This all the way we can write down the things around. Fine. Moving furthermore with the second part, that is position time relation, we will derive the second equation. In the second equation the same graph we are going to continue with, but we are going to take an area of it. So graphically S, so as I told you last time also, S is nothing but displacement. So displacement is nothing but an area of an whole trapezium. Area of an whole trapezium OABC which is a trapezium here, is we cannot directly take out an area. So, we can break down this into two parts, that is, one part is a rectangle and another part is an triangle. So, which is a part as an rectangle? So, rectangle is OADC is a rectangle and triangle is ABD. So, here the triangle is ABD. In the same way, if we take out an area, so that will be OA into OC. OA is on the y axis and OC is on the x axis. So, area of triangle is length into breadth, that is, length is OA and breadth is OC. Same way, area of triangle is nothing but half into altitude into base. So, here it will be half into AD, that is a base, and BD, that is an altitude. So, substituting these values of OA as U, OC and AD as T, and BD as we have derived it before is nothing but V minus U is equals to AT. So, here what we are going to get putting these values around. So, we put OA is equals to U, OC is equals to T. So, it will be UT plus half and AD into BD. So, AD is T and BD is equals to AT. So, AT into T is equals to AT square. So, the equation comes out S is equals to UT plus half AT square. So, this comes out from the position time. The last part of this particular deriving of equation, that is in third equation, is position velocity relation. Now, in position velocity relation, again we are going to take as an whole trapezium, area of an whole trapezium, that is OABC, that will be equals to half of two parallel lines. Half of two parallel lines is OA and BC is a parallel line. So, half of OA plus BC multiply by the perpendicular of it, that is OC. Now, here placing again these values that we have derived it before. So, that will be half into U plus V whole multiplied by T, and here T is equals to V minus U by A. We have derived already from the previous equation, that is V is equals to U, V is equals to U plus AT. From that particular equation we can take out the value of T is equals to V minus U by A. So, putting the value of T in this equation 1, we get half into V plus U into V minus U by A. So, V plus U and V minus U turns out to be like the equation of mathematics, A plus B and A minus B is equals to A square minus B square. Here it comes out to be V square minus U square, and putting 1 by 2 as half as 2 on this side and A also in this side, we get an equation as 2AS is equals to V square minus U square. So, deriving these three equations, we get the values of all the three equations of motion, and this is how we can derive it. Once you are going to write down and draw the graph, you will understand the things more better. Fine. So, we will keep up till this for this lecture.